Drilling Logistics charters a number of offshore vessels to move material to and from various offshore drilling points. These vessels pick up the materials at the port and transport the material to the drilling unit that puts the order in. When the order arrives at the port, it gathers all the materials needed in the order and then loads the vessel with the loading time given. This cycle repeats approximately every 744 hours, but it varies for each item. Drilling Logistics has three slips that load the material into the vessels. The starting point of the simulation has only two slips active. The third one is not used now. When the vessels are not being used, they wait for new orders at a waiting port. Travel capacity within the canals and the waiting areas are not system constraints.
The factors that are needed to work this case are the space and volume capacities of the three kinds of vessel, loading and unloading times, vessel's daily cost, and finally the weather. The last one is divided into wave height and wind speed. It is important to say that the vessels are assigned to a specific rig and cannot serve to other rigs. The rigs desire that the order is delivered in less than 24 hours after the order was placed, but needs to be filled in less than 60 hours to avoid shutdowns. Our objective is to reduce the cost of the vessel fleet maintaining, or if it's possible, improving the current service levels. To model this case, we will need to divide the main process, which is ordering the material, into different subprocesses. These subprocesses are order placement, loading the vessel, waiting vessel, traveling vessel, and unloading the vessel. The unloading time depends also on the material that is transported. In this model, weather plays an important factor. If it's severe enough, then the vessels will have special restrictions during loading and transporting. There are two weather factors to be considered, wind speed and wave height. The weather conditions are on a place for cycles of 6 hours, where the weather will be the same until the next cycle. Both factors could restrict unloading limits and travel limits. Now we will introduce the simulation results. First, the model as is was simulated using the following parameters: 100 replications, 6 months with 1 month warm-up, 2 slips available, and 12 vessels. The responses that we focused on were the over 24-hour delivery rate, over 60-hour delivery rate, and the total cost, being the last one the most important variable to minimize. Afterwards, the model was simulated using UpQuest for Simio in order to determine the optimal fleet size that lowers the total costs. The objectives of this experiment were to minimize the total cost, maintain the over 24-hour rate under 10%, and the over 60-hour rate under 5%. The UpQuest parameters for the experiment were 6 replications maximum per scenario, maximum 500 scenarios, 6 months with 1 month warm-up, 2 slips available, and at least 1 vessel serving each rig. Finally, the variables were carefully tuned and verified using the Kim-Nelson add-in to get the optimal value of all the variables. When we compare the best scenario results against the results of the model as is, we can see that the over 24-hour and over 60-hour rates increased insignificantly due to having less vessels in the system, but still working under the rates restrictions. The total costs were lower by almost 24%, even with the over 60-hour rate increased during the best scenario results. Now we proceed to make the simulation considering having all 3 slips working. We use the same optimization process, using both the UpQuest and the Kim-Nelson add-ins, in order to determine the best fleet size scenario and decide if opening the third slip reduces overall cost or not. The results of the best case shown that the total cost is reduced even more, by almost 40% of the original cost. This is why our recommendations for the case are To open the third slip, also to reduce the fleet size as the best scenario shown in part 1, removing from the fleet the Clapper, the Blair Dandies, the Harvey Hacker, the Donald Rice, and the Marvin Duck. Finally, we would like to recommend to analyze in the future a system where the same vessel can serve multiple rigs.